So here's an example for the upsample. So we will upsample the signal y by a factor of n equals to 2, and we will low pass filter it with the filter given by this array here, as in the previous example. So again, we obtain the polyphase filter, the filter polyphase components, so H0 and H1. So this is our impulse response. These are our polyphase components. So next we need to upsample and do the phase delay for our deblocking. So here we have the Y0 and Y1 will be filtering the Y with H0 and H1. Then we will have here upsampling with phase 0 and upsampling with phase 1. And what we have now is the signal Y of U is the same as if we had first upsampled and then filtered the signal. So we can listen. So we have here Y from the previous example. Here is our Y. And now we will filter Y with these polyphase components of this impulse response. And here we are doing the upsampling with phase 0 and the upsampling with phase 1. So this Y of U here. And we can also listen so this is the Y of U, and we had our downsampled signal Y, and we upsampled. We had our downsampled signal Y here, and we upsampled. So this was some examples using the noble identities. So we can see that we can use this polyphase decomposition and use our polyphase components to filter and exchange filters to obtain filters operating on the lower sampling rate. This can be very convenient. It can save hardware power and computational power. And we've seen this parallel to serial conversion. We've seen blocking and deblocking operations. And that's it for this notebook. And I see you in a different time.